Okay, so we're going to review over test 3, which really is over a lot of sections, right? 5.1 and 5.2, which are kind of the same. 5.4, which is about factoring out the greatest common factor. 5.5 is the factoring trinomials. 5.6 is special factorization. And then 5.7, which is solving by factoring. So let's start with 5.1, and I'm just going to go over kind of a review of what's going to be there. So first off, in 5.1 and 5.2, we have to know how to find the degree of a polynomial, right? So if we have something like, let's say, 4x squared, right? The degree is just 2, right? It's just your highest exponent. But then if we have something like negative 1/2 x squared y cubed z, something of that nature, remember, you just have to add the exponents on the variables, right? So we've got a squared, a cubed, and a raised to the 1 power. So we just add those up. So the degree just winds up being 6 because it's 2 plus 3 plus 1, right? Just 6. And then also, if we have just a number, let's say like the number 7, and I ask you what the degree is, for a constant, the degree is always 0. And the reason is because you can write any variable and then raise it to the 0 power. Remember, anything raised to the 0 from the last test, it just means that it's 1. So therefore, this really isn't there. It's times 1. So therefore, the degree is just 0. Okay? Those are 3 good examples that might pop up on the test. Maybe not, but maybe so. And then, and that was, 5.1 also was addition and subtraction. It's just making sure you know how to understand what a like term is. So this is still 5.1. So if we have something like, 2x squared plus 3xy minus, 4x squared plus 7y. Okay. If we're going to combine like terms here, now it's subtraction. The only terms we can combine are going to be the 2x squared and the 4x squared. These two guys or gals, it doesn't matter, are non-like terms. An xy and a y do not have the same exact variable. So therefore, the only things we can combine are the x squared. So we're subtracting. So I'm going to do 2x squared minus 4x squared. That's a minus 2x squared. I can't do anything with that plus 3xy. Now this minus sign's got to go to the 7. So minus 7y. So that would be us combining through subtraction. Now, if you go back to that, there's addition as well. It's a little easier because you don't have to worry about changing the signs. And then now this is going to be more like 5.2 with multiplication. If we have something like 3x minus 1 times 2x plus 7. Now, this is multiplication, much different than addition or subtraction. Because no matter what, we can multiply, right? Even if it's not like terms, we can multiply. So in this instance, we're going to distribute or FOIL, however you like to say it. So 3x times 2x, that's 6x squared plus 21x minus 2x minus 7. So we combine the middle two terms. So we get 6x squared plus 19x minus 7. Boom. Right? Now, we use this to check our answer in the next few section, which was nice, right? That's part of the reason it's in this section. It's really just a way to check your answer for the future sections in chapter 5. But that's multiplying. Now, I want to do one more multiplying question. If we have something like 7x minus 2y squared, and it's because I have a lot of students that see this. And we just got out of the exponent section, and our brains want to distribute that 2 to both terms. But you cannot distribute that 2 if you have addition or subtraction, if there's more than one term. If you go back to, was it 1.7, I believe, is when this was taught, the distribution, it was always a single term in the middle. It was always just like 7x squared or negative 2y squared. You cannot do this with 2 separate terms. So to multiply, we have to make it into 2 binomials being multiplied. So 7x minus 2y times 7x minus 2y. And then we just do the same thing we did before. FOIL it out. So 7x times 7x, that's going to be 49x squared minus 14xy minus 14xy, and then plus 4y squared. And now look, I've run out of paper, so I'm going to be a little lazy here. This combines to minus 28xy. So that would be your answer. 49x squared minus 28xy plus 4y squared. Sorry about that. But this is a good review. This page here is a good review of sections 5.1 and 5.2 that's going to be on the test. Stuff like this. Knowing the degree, we have to know that for later on. Actually, that's a college algebra concept. And then adding and subtracting like terms is just something we're going to use throughout this whole class. And then multiplying is mainly going to be used to either simplify or to check answers, which is nice because, you know, if we've worked really hard to get an answer, it's a way to check it. Okay. Questions about that? You guys in the class right now? You can raise your hand or pop a question in the homework or in the chat. I'm sorry. So then we skipped over to 5.4, which was mainly about greatest common factor and factor by grouping. So let's look at 5.4. So good questions for 5.4 would state, you know, factor out GCF. And it would be something like 3x squared y minus 6xy plus 9x cubed. Something like this would be a good question. So 3x squared y minus 6y or xy plus 9x cubed. So if I'm going to factor the GCF, which is always the first step in any factoring question, you want to check to see if there's a GCF. First, we're going to look at the numbers 3, 6, and 9, the coefficients. We're going to say, hey, we can factor out a 3, right? We can divide all those by 3. We can factor out a 3. And then if we look at the x's, we got an x squared, an x, and an x cubed. Well, they all at least have an x. And the y's, we have a y, and no y. Well, I can't factor a y out because this y is not there anymore. Or it's not there anymore. It's just not there. Not that it's not there anymore. So therefore, I can't factor a y out. So I can only factor out 3x. Now, this would be considered our greatest common factor, right? That's our greatest common factor. So if I factor these out, I'd really just divide each term by that. Or I can think of what do I need to multiply to get the term. So like if I look at this 3x, what do I need to multiply it by to get 3x squared y? Well, I know it needs another x and it needs a y, right? 3x times xy would give me 3x squared y. I need the minus sign because my sign didn't change. I didn't factor a negative out. And then I need to look at, okay, what do I need to multiply 3 by to get 6? 2. I don't need an x there because there's already an x, but I do need a y. Okay. So 3 times 2 will give me the 6, x, and then the y's there if I multiply these back through. And then what do I need to multiply 3 by to get 9? Oh, that's just 3. And I need 2 more x's, right? And I'm done. And notice a quick check to see if you're done, of course, is to multiply it back through, but also that there's nothing else we can factor out. Of all 3 of these terms, there's not a single value or variable or number that I can factor out still. So therefore, I know that I am done. I've factored this completely, okay? I factored it, well, I've greatest common factored it completely. I'm not looking for the trinomial part. I don't think that's not, you won't be able to factor it as a trinomial either. Okay, the second part, so that's factoring out the GCF, and then we did factoring by grouping. And remember the red flag on this, on when to use it, I shouldn't say red flag, the indicator to use this is if we have 4 terms. Oops, excuse me. So if we have 4 terms, we can use this form of factoring. I'm in the wrong section. I'm going to steal one. These are kind of hard to make up. Off the top of my head. So I'm going to steal one from your book. Let's look at, this is number, I think I did that one. Give me just 1 second, guys. This is number 68 in your homework, actually, on page 378. 4x squared plus 2xy minus 10x minus 5y. And so the indicator that I should use factor by grouping is we have 4 terms, right? 1, 2, 3, 4. And look, there's no greatest common factor. 4x squared, 2xy. Well, there is common factors for the first two, but 5 is not divisible by 2. So I know I can't factor a 2 out of everything. And not all of them have an x and a y, or an x or a y. So, well, they have an x or a y, but they don't have an x completely through, and there's not a y completely through. So remember to do this. Now, if there's subtraction, you've got to move it in to that third term. So I'm going to rewrite this: 4x squared plus 2xy plus negative 10x minus 5y. Okay. And then the goal is to factor each of these to look exactly the same, right? If I factor out this first set, 4x squared plus 2xy, I can factor 2x out, and I'm left with 2x plus y, right? And again, the goal is to make this parentheses match this parentheses. Both of these are negative, so I know I'm going to factor out a negative to make them positive. And then they're both divisible by 5. I think that's it. Yeah, because I can't factor an x or y out because it's not common for each of those terms. But when I do that, notice when I take out a negative 10 divided by negative 5, I get 2x, and I get a positive y. And we kind of hit our goal. This is the way you check it kind of as you're going. These two match. And if those two match, I can just use GCF. Because if they match, they're the same exact factor. And if they're the same exact factor, I can factor them out. So we get 2x plus y times, and it's going to be whatever's in front, the coefficients. 2x minus 5. Okay? Questions about that? Now, if I want to check it, guess what? I just FOIL it out. 2x times 2x, 4x squared. 2x times negative 5, negative 10x. Y times 2x, 2xy. Y times negative 5, negative 5y. I know I'm right. Okay. So these two questions are a good review of factor. I would still look at more factoring out GCF. There's a lot of different questions in that section over factoring out the GCF. And then also factor by grouping. Okay. Definitely going to be on the test. So I'm going to pause there for a minute. Do you guys have any questions from 5.4? Zoomed out. Okay, so the next one, I'm going to let you try this one on your own because there's a lot of different ways to do it. But it's factoring trinomials. And we've got a few different ways. Let's see, this is 5.5 now. 5.5. This is a little better. 5.5, we've got, let me give you two separate types of trinomials. We'll do one where the number's not in front because it's really easy, and then one that isn't. So let's say, I'm going to go to the back of your homework again. Let's say we had something like number 6x squared plus 3x minus 54. We'll do that one. And I want you to try these like a quiz. So there's the first one from this section. And the second one we'll do is like number, let's do one. And they dove right into the weird ones. Give me just a second. Well, I'm going to change it up a little bit, but it's going to be 5y squared minus 9y plus 4. Yeah. So try those two. I'm going to give you just a minute. Try those two, and then we'll get back and we'll look at them. Now, remember, either one of these, all those methods we went over yesterday in class, you could use any one you want. Okay, I'm going to stick to the factoring trinomials by grouping because that's the one I really went over in the lecture. So factor trinomials by grouping. If you want to do a different one that is a-okay, like the box method or the diamond method, whatever you want to do is fine. But I'm just going to stick with this one because it was what was on the video. Okay, I'll give you about 3 minutes. Okay, I'm back. Let's rock through these. Now, look, I know in the like meeting we had yesterday, I guess the class meeting, not the video, we didn't mention one of these. That was just really kind of easier to do. And now look, you can still use the factoring, you can use any type of factoring trinomials on this. It's just a lot easier when the x squared's by itself. We can just post the 2 parentheses, put x here. Think of FOILing. We know it's x times x is going to give me x squared. But then we can just think of what 2 numbers multiply to give me 54 and add to give me a positive 9. I mean, 54, we know is what 54 times 1 is. What's divided by 227 times 2. And then it's probably divisible by 3, like 18 times 3. That's not going to work. And then let's say it's 9 and 6, right? But the 6 has to be negative. So it's going to be a positive 9 and a negative 6. Now look, this only works if that x squared is by itself. It will not work if our squared term has a coefficient that won't go away, okay? So just keep that in mind. If the square term has a coefficient, they consider this a. I mean, if you watch a few videos, you'll see they'll mention this is A, this is B, and this is C. That's for a solving thing we're going to go over at the end of this class, actually. But if that A is there, if the A is not 1, right here, the A is really 1, right? If the A is not 1, then we have to use some other method. Now, I'm going to do factoring trinomials by grouping. again, you can check to see, and I don't mind to go over if you hit the right thing on yours to see what you did wrong. But to do factoring trinomials by grouping, the AC method, you multiply 5 times 4. I'm going to write this over here. You get 20. And two numbers that multiply to get 20 to add to get -9 are actually going to be -5 and -4. So you're going to split that -9 apart. You're going to say 5y squared minus 5y plus -4y plus 4. Okay. And then we're going to put parentheses. Now we're just going to do this by factoring by grouping, right? 4 terms, factoring by grouping. I can take out a 5y from this and I get y minus 1. Now I need to change the signs here. Look, I've got a negative and then a positive. Here I've got a positive and a negative. So I know I need to take a negative out and I can take a 4 out. And it changes the sign. So this first term becomes positive y. Second term becomes -1. These match. So I have my y minus 1 and 5y minus 4. Okay. And again, I could FOIL this out. Y times 5y, 5y squared, minus 4y minus 5y, -9y, and minus 4 gives me a positive 4. Okay. So that works out. Now, there's a lot of questions in that section. These are just two that are similar to what's going to be on the test. So if you're going through there, make sure, and I think your book calls this like objective A and then objective B. And then everything else is kind of mixed up in between. Okay. Questions? Did you guys get it right doing that? I think box method is what we chose yesterday, right? That was the favorite of the methods overall. And that's fine. There's nothing wrong with that. Find your way and do it. That's not a big deal. Wait, hold on. Let me. Make sure. Yeah. Let's do one more. And really it's important because of how it's going to be answered. This is like number 22. 25x squared minus 30x plus 9, which seems like a huge, these are going to be big numbers. I'm going to do it the same way. This factoring trinomials by grouping. 25 times 9 gives me, oh man, I'm going to bust the calculator out. Well, 9/4, that's, is it 225? Yeah, 225. And then I've got to find stuff that multiplies to give me 225. This is going to take a little bit. So I know it's divisible by 5, but that's 45 times 5. That's not going to give me, both these have to be negative, right? To add up to negative. That's not going to get me to 30. It's not divisible by 10. What about 15? Ah, yeah, there it is. 15 and 15. I can make both those negative. That multiplies to give me 225 and adds to give me that -30. So I'm going to split this apart and I get 25x squared minus 15x. I'm just going to automatically put in parentheses because it's factoring by grouping. If you're doing the box method, just keep rocking and rolling. I'm going to factor 5x out of here, and it gives me 5x minus 3. I'm going to factor out a -3 here to change the sign. So that would give me 5x minus 3. And I actually wind up with 5x minus 3 times 5x minus 3. Okay. Now I know I did that pretty quickly. It's just like the example above, if you're working the example above, because it's not really about the answer on this one. It's how it's answered and the type of trinomial it is. This is a special trinomial. It's considered a perfect square trinomial because these two are the exact same. You could write it this way, or you could write it as 5x minus 3 squared. Either one is okay, because it's the exact same. That's a perfect square trinomial. Questions about any of these? This is actually kind of 5.6 and 5.5 right here. But any questions? I'm going to keep rocking and rolling. I know I sped through that last one, but it was mainly about how to answer it. So 5.6, the main thing I need you to know from 5.6 is the difference of squares. So if we see one, and this really is just a shortcut method, So in 5.6, it's more about, let's say we had, let me make one up, 4x squared minus 25. 4x squared minus 25. If I see that and ask you to factor completely, because that's what it's going to say, factor completely, I need you to think, oh, wait, hey, I can write this first term as something squared, and I could write this second term as something squared. And we're going to use this in the future. That's why it's I kind of put that on there. So let's see, we get 2x minus 5, and then 2x plus 5. Remember, it was you take the first term, subtract, and add. Okay, I would look back at these. In 5.6, they are considered objective B, I believe. On page 396, it's numbers 13 through 24. I would get comfortable with doing these. Actually, I would get comfortable with doing 13 through 13 through like 21, ones like that. So 13 through 21, get comfortable with those. Okay, and then 5.7 is on solving. Now I'm going to do just some basic solving questions. I go more in detail, of course, in the lecture video. But the goal is to get 0 on one side, factored completely, set the factors equal to 0, and solve. So if we looked at something like, let's say we had x squared, easy to make up either. Let's say we've got x squared equals x plus 6. I hope this works. If not, I'll have to change it. But if I've got x squared equals x plus 6, remember, you've got to get 0 on one side. We need a positive x squared. So I'm going to move both these terms over and write them in descending order. So if I subtract the x over, it goes next to the x squared. Subtract the number over, subtract the x. So now we can actually say this is, this factors in that easy way, right? X minus 3, x plus 2. Multiplies to give you the negative 6, and then adds to give you that negative 1 there. Okay, so that's x minus 3 and x plus 2. So we factor, so we set one side equal to 0, factor it, set each of these equal to 0. And we get x equals 3, right? Add the 3 over, subtract the 2 over. And x equals negative 2. So that's a basic example of solving. A very, very basic example on solving. Now, you need to go through and look at those questions because there's a lot more that are in that solving section, but that's just a very, very basic example of it. Okay. Any questions? I'll tell you there's 20 questions on this test. And they're pretty scattered when it comes to what sections they're on. It's not that one section kind of dominates the other by any means. And if you haven't seen 5.7, just go back. You're going to go, oh yeah, that's super easy because I know how to factor. I'm going to stop the